On November 2024, a study published in Physical Review Letters might have made an incredible contribution to simulation theory. Researchers now have a model that, if environmental factors are known, can predict what a single photon looks like and even directly produce its visual output. In this research conducted by Ben Ewan and Angela Dimitriadou from the University of Birmingham, a photon's lemon-shaped first visual representation was created by inputting the frequencies of electromagnetic fields surrounding the photon, the density of the medium, and the quantum state of the photon into the model. This visual is not a direct photograph, but the result of mathematical modeling and simulation. Saying that everything we see can fundamentally be explained by a model, or more speculatively, a simulation, would not be an overstatement. Following this research, we could model double-slit experiments without physically performing them. By inputting the variables, we could visually see, as if watching a match on TV, through which slit the photons pass, marking the beginning of an entirely new era. A photon is known as the fundamental building block of light and one of the smallest units in the quantum world. However, what this paper reveals is that more than just being a light particle is needed to visualize the photon. When scientists input the frequencies of the electromagnetic fields around the photon, the matter density of the medium, and the quantum state of the photon into the model, the true shape of the photon emerged, a lemon-like visual as seen on the screen. This is precisely where simulation theory comes into play. The need for external variables for the emergence of visuals provides a new perspective on the idea that the universe might be a simulation. Indeed, everything we see could be the result of an equation. The photon itself means light and is the fundamental unit of all visuals around us. However, the image of the photon obtained in this study was not simply a captured photograph, but a simulation created as a result of mathematical modeling. What is interesting here is the necessity of adding various inputs to the model to create a visual. At this point, all philosophers might need to burn their existing theories and rewrite their philosophies from scratch. This study seems to have fundamentally redefined the concept of existence. In this research, the physical properties of the fields surrounding the photon, namely the electromagnetic field frequencies, were entered into the model one by one. Following this, the matter density of the medium through which the photon propagates was encoded. Finally, the quantum state of the photon, whether it was entangled or in superposition, was numerically defined. At the end of the day, the model was executed and the photon's image was obtained. According to simulation theory, our universe could be a computer simulation. If this is true, everything we see, like the image of this photon, must also be the result of some kind of algorithm. The model used in this study acted like an equation that took electromagnetic fields and quantum states as inputs and produced visuals. In other words, the photon's image is essentially the result of a series of mathematical and physical variables. This situation might be the first time we have reached a result that so strongly supports the main premise of simulation theory. This premise suggests that the creation of visuals or reality requires an underlying computation, which is almost a cornerstone of all simulation theory research. If the image of the photon emerges as a result of mathematical modeling, this finding could indicate that the fundamental unit of reality is calculable. But where and how are these calculations performed? The idea of the universe being a simulation offers a potential answer to this question. According to the model, even the slightest change in the variables can alter the photon's visual representation. This leads us to an astonishing point. The fact that the shape of the photon changes depending on environmental factors could suggest that time and space also vary according to an algorithm. According to simulation theory, time and space are also the results of computations and may differ based on different inputs. This paper is not just about visualizing a photon, but also about questioning how reality itself is formed. The necessity of variables for the creation of visuals raises the following striking question regarding simulation theory. If you had a computer capable of modeling the entire universe and wrote the universe's wave function, could you truly model the universe? The essence is that we are progressing step by step into simulation theory. Thank you for watching our video.